Hi folks, CodeTutor here and my name is Anil Deshpande. Welcome to the second video of AI orientation. In the previous video, as we were closing our discussion about the classical AI, we said that there were certain limitations with the classical AI, and the next obvious choice was the evolution of machine learning. If you recall, one of the main limitation with classical AI was people still had to write complicated programs. They were much advanced, but they still had to write the programs. That is where the scholars decided to change their approach towards AI. Instead of writing the programs, what if the machines could write the programs on their own? And this thought process basically led to evolution of new concepts, that is machine learning, wherein people thought it would be better if we allowed the system to learn from the data. The key word here is system to learn. Now the question is how to make a system to learn. You can replace the system with a machine and it still pretty much means the same thing. That is how to make machine learn, or for that matter, how to make machine mimic human learning, how humans learn. So the crux of the matter was, if we want to build systems where machines can mimic the human learning, the first thing that we have to understand is how humans learn, and then hopefully we should be able to solve this particular puzzle. So in this video, it's all going to be discussion about how machines learn. So let's concentrate on how humans learn. We know for sure that for humans, learning happens through brain. What does brain contain? It basically contains billions and billions of neurons. Neurons have this thing called as synaptic connections, which are basically the tentacles of the neuron cell, which are connected with other neurons tentacles, and the gap between the two tentacles is called as synaptic connection, and the signals that pass through those connections, which is called as firing of a synaptic connection, that is at the center of human learning. So now, without doubt, we know that neuron is where learning begins. Well, what exactly happens in the neuron when we are trying to learn? Well, as per the neuroscientists, as more and more frequently activated neurons fire together, their connection basically strengthens. So, when you are trying to learn a particular skill, and if you are constantly activating a certain set of neurons and certain set of neuron connections, then they will become more efficient at firing, and that is in a way learning. You can see that when you are trying to learn piano, the coordination between the fingers while you are also imbibe the musical knowledge, that is being continuously trained by continuously firing the same set of neurons. The technical term for this is called long-term potentiation, or LTP. The second part is, as you are learning, you are creating new neurons, and not only that, you are establishing the connections between the new neurons and the old neurons. This especially happens when you are learning a new language or a new skill. If you already know English and if you are trying to learn Hindi or any other language, you are basically creating new set of neurons. And not only that, you are establishing the knowledge between the English and Hindi, and this is how you are able to correlate and see the patterns between the different languages and the skills. This is called as neurogenesis and synaptogenesis. Genesis means creation. Neurogenesis, new neurons are getting created. Synaptogenesis, new connections are being created. And then the more you use the same set of neurons, they become more efficient at firing synchronously. The more synchronously they fire, quickly you are able to recall the associated knowledge with it and basically able to apply it in your day-to-day life. And not only that, now you need not have to do it consciously, it happens all effortlessly. So this is very much visible in sports persons. As they practice more, they will become more effortless. So effortless mastery over moves in sports and tasks is associated with this phenomena. It is called as network efficiency. That is, the network between the neurons become more efficient at firing in a perfect synchronous order. And then there is a concept of getting rid of unused neurons and making optimal use of resources. That is, in a way, unlearning and forgetting the less used skills. The technical term is pruning and chemical changes that happen when you don't use a certain set of neurons. If this sounds counterintuitive, I will give you an example. This is a well known established fact that when you are a baby, we have the ability to recognize each individual different shape and their faces. But as we grow old and become adult, recognizing the faces of the sheep and ability to distinguish one sheep from another shape is not much required social skill. What is more important is whether we are able to recognize people's faces and their emotions. That is more critical skill for our survival as a human race. So as we become adult, we basically lose the ability to distinguish between the shapes, not unless you are a shepherd, of course. That is exactly the reason why if you don't program in a particular programming language for a long time, you slowly start losing those skills because you are concentrating on learning something new. So in a way, your brain is trying to make optimal use of resources. You don't want to retain information about things which you don't use on regular basis. That's the whole idea. So by now we have a pretty fair idea of how learning happens in humans through a neuron. But this still doesn't answer our question, that is how to make machines mimic the human learning. So the other question that we are asking is, if this is how learning happens in a biological neuron, what is a digital equivalent of a biological neuron? Well, a function that you write in a program can be treated as neuron. What is a neuron at the end? It takes signals, then chemical reaction happens, and then it sends out the signals. In the same way, in a function, it takes certain inputs and then according to some logic, it does something with it and then it gives the output. So a function is a digital equivalent of a neuron. If I decide to represent a function as a node, there can be multiple nodes or multiple functions, and then you can give input to the first nodes that are there in the first layer. So you basically give certain inputs, and not only that, you give certain weights. If you are wondering what is a input, what is a weight, let me try to simplify it. Let's assume that you are trying to make a decision on whether it is going to rain today. The output should be either yes, it is going to rain, or no, it is not going to rain. Or more probably, it will not be a simple yes or no answer. It will be a probabilistic answer. 70% chance of raining, 30% chance of raining. Well, if that is the output, what is the input? Humidity. Is there a wind? Is it sunny? Those could be the inputs. And what is the weight? Weight is how much weightage you want to give to each of these inputs. Once again, these are certain numbers. You basically give these inputs to the function, and function takes this input and does some calculation, and then depending upon the result of the calculation, it may decide to send the output to the next function that is there in the next layer, or it may not decide to send the output to the next function in the layer. Strength of the value that it sends to the next neuron is dependent on some calculation. That calculation is called as activation function in machine learning parlance. Typically, these functions are mathematical functions like sigmoid function, hyperbolic tangent function, ReLU, that is rectified linear unit, and softmax. These are some of the calculations that are done in the individual functions to take input and weight and come up with a value that can be passed on to the next layer of digital neurons, which are nothing but functions. And then the same thing happens in the neurons that are present in the middle, and they might send the information to the next functions. And then based on what is the value that we are getting, those neurons give us certain values which are based on certain probability to tell that yes, it is going to rain or not rain, by how much probability it is going to rain. As you can see here, there is a network of nodes here. The nodes that are there in the input layer are called as input layer. The nodes that are giving the output are called as output layer, and the nodes which are present between these input and output are called as intermediate layer. And this whole thing is a network of neurons, and that is where the term artificial neural network comes into picture. So machine learning is dependent on this concept of artificial neural network. But you might still be asking the question, how does this artificial neural network, ANN, of machine learning mimic human learning? Well, when you are giving this input and weights to the neural network, certain inputs and weights activate certain specific pathways. That is in a way mimicking the LTP phenomenon. Then there are certain advanced artificial neural networks called as NEATs, that is neuro evolution of augmenting topologies, where new nodes are dynamically added and removed from the ANN architecture. Typically, in the lower end of the ANN, the architecture is frozen, but there are some advanced architectures where the nodes can be added and removed dynamically. So once again, that mimics neurogenesis and synaptogenesis. And when you realize that there are certain insignificant paths or redundant paths which are not necessary and are not really contributing to the required result, then you basically kill certain paths. This is nothing but a mimicking of network efficiency. And last but not the least, which is you will stop giving certain weights which are not contributing to the desired results. So you will start reducing the insignificant weights which are not giving the proper output that you want. And that is nothing but pruning that we see in the human neuron. So this process of adjusting the weights and bias of the network through a systematic procedure so that it accurately maps inputs to the desired output is nothing but training. This is what training means in machine learning. We have so much got focused on learning part, we forgot about the another important aspect in machine learning, which is data. At the end of the day, the machine can learn if the quality of the data is good and you do lot of data processing. And when it comes to data, it is all about inferencing based on the data. And what is the field that is associated with inferencing based on the data? Statistics. Once again, lot of concepts from statistics like probability and distribution, estimation, regularization, Bayesian statistics, statistical inference, error metrics, and evaluation all are applied to work with the data and improve the quality of the data that need to be supplied to the ANN so that ANN can be trained to give desired outputs. Statistics is not only used for pre-processing of the data, it is very much part of the training and then checking the performance of the solution. So in a way, statistics is integral to the machine learning, guiding the pre-processing of the data through techniques like normalization and feature selection, optimizing model training with methods such as gradient descent, and evaluating and validating model performance with metrics and tests across all stages of development in machine learning. And in the earliest stages of machine learning, it was all about inferencing based on the data. And that is the reason why, if you go back to the earliest history of machine learning, before it got named as machine learning, it was called as applied statistics, or it was part of statistics and was called as applied statistics. Later, it came to be known as machine learning. So now we know how machines can mimic the human learning. Having understood how human neurons work and how artificial neurons and neural networks are mimicking the human learning, it is high time to move on to understand the more advanced intricacies of machine learning. And this is the perfect segue to introduce some of the advanced branches of machine learning, that is supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. So let me stop now. We will continue our discussion into the various branches of machine learning in the next video. So stay tuned. That brings us to the end of this particular video. Don't forget to like, comment, share the video and subscribe to the channel. Take care. Bye.